You probably think your life is real, but there is a mathematical chance that you are nothing more than a character in a super advanced version of The Sims. If you have ever felt like the world around you is just a bit too perfect, or maybe a bit too weird, you might be onto something much bigger than a simple coincidence. Have you ever stopped to wonder why the entire universe seems to follow strict mathematical rules, almost like it was written in code? Today, we are going to look at the evidence that suggests our entire existence, from the coffee you drank this morning to the stars in the farthest galaxy, is actually running on a giant computer built by a civilization way more advanced than us. By the time we finish, you might never look at the same way again, and you will understand why some of the smartest people on Earth are actually convinced we are living in a digital dream. The idea that our world isn't real isn't actually new. A long time ago, a guy named Plato talked about an allegory of the cave. He imagined people tied up in a cave, only seeing shadows on the wall. To them, those shadows were the real world. They didn't know there was a whole sunlit world behind them. Later on, a philosopher named René Descartes wondered if an evil demon was tricking his senses into feeling and seeing things that weren't there. But back then, they didn't have computers, so they couldn't quite name what they were feeling. Fast forward to today, and we have things like the PlayStation 5 and high-end gaming PCs. This has changed the conversation from demons to data. This shift is what we call the simulation hypothesis. It is the serious proposal that all of existence is an artificial simulation. It is not just a movie plot like The Matrix. It is a theory being debated in the halls of Harvard and NASA. We are moving from wondering what is life to asking who is the programmer. In 2003, a professor at Oxford University named Nick Bostrom wrote a paper that changed everything. He didn't just say maybe we are in a simulation, he used logic and math to back it up. He created what we now call the simulation trilemma. He said that at least one of three things must be true. First, he suggested that maybe civilizations like ours always go extinct before they get smart enough to build a universe-sized computer. This is a pretty dark thought. It means we might be headed for a dead end. Second, he said that if a civilization does get that smart, maybe they just don't want to run simulations. Maybe they find it boring or think it is wrong to play God. But the third option is the kicker. If civilizations do survive and they do want to run simulations, they wouldn't just run one, they would run millions of them. Think about it. If you had a computer that could simulate a whole world, you wouldn't just do it once, you would run different versions to see what happens. If there are millions of fake universes and only one real one, what are the odds that you are in the real one? Mathematically, the odds are millions to one that you are a sim. Bostrom's argument is so solid that even people like Elon Musk have said the chance we are in base reality is 1 in billions. To see why this is so believable, we just have to look at our own technology. Let's go back to 1972. The biggest game in the world was Pong. It was just two rectangles and a dot bouncing back and forth. It didn't look like reality at all. But look at where we are now, only about 50 years later. We have games like Cyberpunk 2077 or Red Dead Redemption 2, where you can see the light reflecting off a puddle or the way a character's eyes move. If we go from Pong to photorealism in 50 years, imagine what games will look like in 10,000 years. That is a blink of an eye in the history of the universe. Eventually, games won't just look real, they will feel real. We will have virtual reality that plugs directly into our brains. If we can reach a point where we can't tell the difference between a game and reality, then who is to say it hasn't happened already? We are the living proof that a species can and will try to recreate reality with code. If our world is a computer program, we should be able to find the pixels. In a video game, if you zoom in far enough on the screen, you see little squares of color. Well, in our universe, physicists have found something very similar. There is a limit to how small things can get. It is called the Planck length. You cannot have a distance smaller than that. It is like the smallest possible unit of space. The same thing goes for time. There is something called Planck time, which is the shortest tick of the clock possible. If the universe were truly natural and infinite, why would it have a minimum resolution? The fact that our world is quantized, meaning it comes in little chunks, is exactly what you would expect from a digital file. It is as if the universe is made of bits of information rather than actual solid stuff. Some scientists have even claimed to find actual computer-like error-correcting codes hidden inside the math. One of the biggest mysteries in science is the speed of light. Nothing can go faster than 299,792,482 meters per second. But why? Why is there a speed limit at all? If you think about the universe as a simulation, this makes perfect sense. Every computer has a maximum processing speed. The processor can only handle so much data at once. In this view, the speed of light is the clock speed of the universe's motherboard. It is the fastest the hardware can move information from one place to another. This explains why time slows down when you move fast, which is something Einstein proved. In a video game, if too much is happening on the screen at once, the game starts to lag. Time dilation in space might just be the universe's way of lagging to make sure the computer doesn't crash while it processes your movement. This brings us to one of the weirdest parts of science: quantum mechanics. There is a famous experiment called the double-slit experiment. It showed that tiny particles, like electrons, behave differently when they are being watched. When nobody is looking, they act like waves. But the moment a scientist observes them, they snap into a specific position and act like solid particles. In the world of gaming, we call this rendering. To save memory, a game like Grand Theft Auto doesn't draw the entire city at once. It only draws the street you are currently looking at. The rest of the city exists as data, but it isn't real until you turn your head. This is a huge trick used to save processing power. If our universe works the same way, where things only become solid when we observe them, it would save the great programmer a massive amount of energy. Another reason people think we are in a simulation is how perfectly the universe is set up for us. There are certain numbers in physics, like the strength of gravity or the charge of an atom. If any of these numbers were off by even a tiny fraction, stars would never form, or atoms would fly apart. Life would be impossible. Scientists call this the fine-tuning problem. It is like the universe was built for us. Now, you could say it was a lucky accident, or you could say a god did it. But in the simulation theory, it is even simpler. Someone just typed those numbers into the settings, they set gravity to 1.0 and electromagnetism to 1.0 so the simulation would work. Have you ever heard of the Mandela effect? It is when a huge group of people remembers something one way, but the real history says something else. Think about the Berenstain Bears. Lots of people swear it used to be spelled Berenstain with an E. Or the Monopoly Man. Did he have a monocle? Most people say yes, but he actually never did. Pop culture loves to call these While psychologists say it is just how our brains misremember things, simulation fans think these might be patches or updates to the system. Maybe the programmers changed a detail in the past and didn't quite wipe our memories correctly. It is a fun way to look at why we feel like things are off sometimes. Then there is the Fermi paradox. We look out at the billions of stars in the sky and wonder, where is everyone? If the universe is so old and so big, there should be aliens everywhere. But we see nothing, just silence. If we are in a simulation, the answer is easy. The simulation might only be designed for one species, us. Simulating multiple intelligent alien civilizations across millions of light years would be incredibly expensive for the computer. To save resources, the programmers might have just given us an empty sky. We are in a single-player mode. Of course, not everyone is convinced. One big problem is the complexity barrier. To simulate just one human brain with every single atom and neuron would take a computer bigger than we can even imagine. Simulating a whole universe would be almost impossible. There is also the infinite regress problem. If we are in a simulation, who created the people who created us? Are they in a simulation too? It is like a set of Russian nesting dolls that never ends. At some point, there has to be a base reality. Why can't we just be in that one? Occam's razor is a rule in science that says the simplest explanation is usually the right one. The simplest explanation is that the world is just real and made of matter, not code. This leads us to a big question. If we are in a computer, does it change how we should live? Some people think it means nothing matters. If it is all fake, why follow the rules? But others think it gives life more meaning. If we are here for a reason, maybe as an experiment or a piece of art, then our actions still have consequences. Even if you are made of code, your pain feels real. Your love feels real. Your joy feels real. A digital diamond is still a diamond to the person holding it in the game. Whether we are made of atoms or bits, we are still here experiencing this incredible thing called life. Scientists are actually trying to test this right now. Some are looking for the edges of the universe or trying to find signs of rounding errors in the laws of physics. They want to see if the universe has a maximum resolution that we haven't found yet. So, the next time you see something weird, like a bird that seems to hover perfectly still or a déjà vu that feels a bit too strong, don't just brush it off. You might just be catching a glimpse of the hardware behind the curtain. We might be characters in a game, but at least we are starting to figure out how the game is played. If you want to see what happens when the simulation actually breaks, click the video on your screen right now.